Hello Year 11, here I am to help you with your revision, and today I'm going to talk to you about the formation of waterfalls. You know, those beautiful features where water falls vertically over a drop in the river channel. So, to begin with, 90% of the world's waterfalls are formed by a layer of hard rock sitting over a layer of softer rock. We can call this less resistant rock, and the harder rock is more resistant. So whilst I shade these in some beautiful colours, why don't you answer a question for me, which is, what kind of rock sits on top of the softer, less resistant rock? Casey. Indeed it is, the hard rock. Well done. So now our landscape is set for the river to flow over the surface of these two rocks. The river is eroding both of the rocks as it flows over them, but it will erode the softer rock much faster because it is less resistant. So I'm going to draw it with a nice thick arrow. Whereas the hard rock, which is more resistant, is going to be eroded at a much slower rate. Which type of rock is going to erode the fastest? Sam. That's right, the soft rock, because it's less resistant. We call this, the fact that there are two different rates of erosion, we call it differential erosion. Because the soft rock is eroding quickly and the hard rock is eroding slowly. What is differential erosion? Ryan. Exactly right, well done. When the soft rock erodes quickly, whereas the hard rock erodes slowly. What this does is it causes the softer rock to have a reduction in its height. So the soft rock now sits at a lower level than the hard rock. Compare the new levels of those two rocks for me, please. Aisha. That's right, the softer rock is now at a lower level than the harder rock. We have created a small vertical drop. What have we created because of the differential erosion? Fuad? Great, a small vertical drop. And why has that small vertical drop been created? Catherine? That's right, because the soft rock is eroded faster than the hard rock. Differential erosion. Nice one. So this is the very beginnings of our waterfall. Let's fast forward a little bit in time to see what happens next. And it's going to look something like this. We still have our harder rock sitting on top of our softer rock. But the vertical drop has increased in height, as you can see. And the water, or the river, now flows over that vertical drop and down towards the new level of the riverbed. a lot of that flow is going to continue downstream. But some of it is going to splash back and hit the softer rock at the bottom. What happens to some of the water flow or the river flow as it falls over the vertical drop? Harris. Yes, well done. It splashes back and it hits the softer rock. This will erode that softer rock by the process of hydraulic action. And that is the power of the water crashing against the soft rock and weakening it. What is hydraulic action, please? Narwan? Yes, well done. It is the power of the water crashing into the rock and weakening it. This creates an indentation in the softer rock. And we can say that this is the first stage of our waterfall formation. What does the hydraulic action acting on the soft rock create? Wael? Yes, an indentation. Well done. So the hydraulic action weakens the soft rock and small fragments of the soft rock break off and collect at the bottom of the waterfall. Now that the soft rock has been eroded and pushed back, it leaves an overhang of the harder rock. That is a piece of the hard rock that is left unsupported with free space underneath it. What do we call this part of the hard rock that is now unsupported? Fuad? Good, the overhang. So let's see, and we can say that that is the second stage of our waterfall formation. Eroded soft rock from hydraulic action, number 1. Number 2, harder rock overhang is left. Let's see what happens next. Fast forward a few thousand years and you will see something more like this. The first thing to notice is that our hard rock overhang, which was here, has now collapsed because it is unsupported. What has happened to our hard rock overhang, please, Zainab? Well done. It has collapsed. Why has it collapsed though, Zainab? Good, because it is no longer supported by the softer rock, which has been eroded. Lovely. And that hard rock is now going to collect as fragments at the bottom of the waterfall on the river bed. The flow of the water is still falling over this vertical drop, with much of the water continuing downstream, but there is now much more energy in the water because the height of the waterfall has increased. and that causes swirling currents of turbulent water to move those fragments around and to again splash back and hit the soft rock wall. Why is the energy in the waterfall now greater than it was previously? Laura? Lovely. Yeah, exactly right. Well done. Because the waterfall is now higher, and so it has a greater distance to fall, which increases its energy. What does that energy, the power of that water now do? Hasina? Yes, it will create turbulent water that moves those fragments around and also continue to splash back and hit into the wall of softer rock behind it. Great. So, overhang collapses. And that is what we can say is our third stage. Fragments gather on the riverbed, can be our fourth stage. Now what happens here is that those fragments being rolled around, moved around on the riverbed are going to erode it downwards and drill the riverbed downwards through the processes of corrosion and abrasion, which are both forms of erosion, but also the power of that water crashing into the bed will cause hydraulic action to further increase the rate of erosion. And all of these processes together will create this area of deeper water directly beneath the waterfall, which we call a plunge pool. Explain to me how the fragments of more resistant rock increase the rate of erosion. Enzo. Yes, well done. So those fragments of resistant rock are rolled around in the turbulent water, and that causes corrosion and abrasion to drill down and lower the level of the riverbed. Good. What other form of erosion is also helping to increase the rate of erosion? Mikhail? Yes, hydraulic action. And what is that? Good. It's the force of the water acting to weaken the rock. Well done. Now, as mentioned, we still have some splashback hitting the soft rock wall behind the waterfall. So the undercutting continues, and that will create another overhang, and the whole process will repeat. As a result, the waterfall will retreat upstream. So it happens like this. Further erosion of the soft rock will push the wall of that soft rock further back in a process called undercutting. The overhang will develop again and become unstable, and further collapse occurs. More erosion happens on the wall through hydraulic action. More undercutting, more collapse. And over time, this whole waterfall feature will retreat upstream. Once the water has started to erode the soft rock again using hydraulic action, what will happen to the soft rock? Good, thank you, Kizar. It will be eroded and the hard rock will be undercut. What then happens to our overhanging hard rock? Hamza? Excellent. It will collapse. And then what can we expect to happen? Sakdio? Good. More soft rock is eroded and undercut, and the process continues. What can we say happens to the waterfall as this process repeats over and over? Please, Mohammed. Very good. The waterfall retreats upstream. And what it leaves behind is a steep-sided gorge. That is a sheer wall of rock either side of the river channel, where the waterfall has cut through as it retreats upstream. So as the waterfall retreats upstream, what landform does it create? Ifra. Very good. Yes, a steep-sided gorge. Now, what is a steep-sided gorge? Melanie. Yes, good, well done. It's two steep, rocky sides either side of the river channel. So, that is the formation of a waterfall. The only thing that remains is to identify a particular case study of a waterfall. Now, you have been studying the high force waterfall on the river Tees in northeast England. Being able to name a particular waterfall is very useful to show a higher level in any answer you give, and it will also be useful to mention some specific facts about this waterfall. So first off, the height of high force waterfalls on the River Tees is 20 meters. It would also be very helpful to name the hard, more resistant rock. And that is an igneous rock. Let me put this here. An igneous rock, which means it's formed from volcanism to create, and its specific type of rock, igneous rock, is called dolerite. Now, it would also be useful to have a name for our softer rock, which is Carboniferous limestone. And with those facts added into an answer, especially if it was a 9 marker, you would be able to really show that you have the knowledge of how a waterfall is formed, but also you can apply it to a real world situation. So very quickly, can you please tell me what is the name of our waterfall case study and where is it found? Aaron. Yes, well done. High force waterfall on the River Tees. But where's the River Tees? North East England. Very good. How high is high force waterfall? Please. Hisham. Sorry, Hashim. I'm always doing that. Hashim. Yes. Very good. 20 meters. And what can you tell me about the rock types that we might find at high force? Farhan. Good. We have 2 types. We have the igneous dolerite and we have the carboniferous limestone. But which is which? How can we describe the 2 of those? Afia. Lovely, exactly right. We have the igneous dolerite as the hard rock and the carboniferous limestone as the softer rock. Jumping back a little bit, the fact that they erode at different rates, how do we refer to that kind of erosion, please? Newman. Yes, well remembered. Differential erosion. Good stuff. Great. Now, what I recommend you do is, first of all, there's an image coming up which you can freeze frame and then try and identify the different numbers on a real life photograph. And after that, I recommend you go through, fast forward, and find these diagrams, making copies for yourself, and instead of just labeling it with key terms, annotate it with well-developed explanations of each stage, so that you can then write about it in similar fashion in an exam answer. Okay, well, best of luck, have fun with your revision, and I'll try and be back with another one soon. Bye bye.